Hi, welcome back to 4.4 Problems in Two Dimensions. We're now looking at our second example. In this example, we're going to solve an oblique triangle. We're going to be given some information. We're going to have to draw the triangle and then solve some things that they're asking about that triangle. So before we get started, I am going to talk a little bit about the ambiguous case because this one of the questions here in part B asks us to check for the ambiguous case. So the ambiguous case, okay, it occurs, so ambiguous case, it occurs when two sides and an uncontained angle are given. Okay, in class we call this type the side-side angle. It's because we're given two sides and then an angle outside of those two. It actually kind of looks something like this. We'll be given one side, we'll be given the other side, and we're given an uncontained angle. Okay, so whenever you get that set up, you know you're going to have to check for the ambiguous case. What the ambiguous case just means is that two possible triangles will exist. Okay, so I'm just going to add that in here. We'll need a check for two possible triangles. Okay. The reason why there's two possible triangles is because when you're given this information, you're never ever told how long this side is, and you're also never ever told the angle right here. So when you draw this length here, you're kind of making a guess where this is. You're also making a guess on this angle. So if you think of this as like a door that's on a hinge and the hinge is right here, this can pivot and swing, and it's possible that this length could swing somewhere out over here, and then the triangle, we end up having a smaller version of it. So we'll see examples of this when it comes up. For now, what we just need to know is that the ambiguous case happens whenever we're given a side-side angle. And if we are given a side-side angle, we'll need to check and make sure that we draw both triangles that represents the information. Okay, so let's get this question started. So we're told Patina, Quentin, and Romeo are standing on a soccer field. Quentin is 23 meters from Romeo. Okay, that's actually something that we can draw out. Quentin to Romeo, 23 meters. It says from Quentin's point of view, so from right here, when Quentin's looking out, it says the others are separated by an angle of 72. So that means there must be an angle of 72 here. Okay, I'm going to start to draw that out. Okay. From Patina's point of view, so Patina is going to be somewhere up here. It says the others are separated by an angle of 55. So P's up here. Maybe we have an angle of 55 there. Okay, so I'm going to go ahead. I'm going to finish drawing this. Then there to there. There's an angle of 55 degrees there. Okay. All right, so there's my two angles that are given and a side length. Okay. All right. Now what I'd like to do is I'd like to figure out what this missing angle is, because in part A it says sketch a diagram of the situation. So we've already started to do that. And then it says why is a triangle that is formed an oblique triangle? So this missing angle here, I know all interior angles add up to 180. So that angle is going to be 180 minus the other two. So minus 72 minus 55. And I believe that's going to work out to 53. Let's just do a quick check. Minus 55, yeah, 53. Okay, so if I had to classify this triangle, I know it's oblique because there is no right angles. So I can just say, since triangle PQR has no right angle, it is oblique. Okay. All right, part B. Is it necessary to consider the ambiguous case? So, with the information that's given, is it possible for us to have two different triangles? Okay, so we've talked about the ambiguous case in class already, and we said it only occurs when we're given a side-side angle. So just two sides and one angle. So the information we're given, I can see that this is actually one side and two angles. This is side angle, angle. Okay. So we don't need to consider the ambiguous case. So it is not necessary to consider the ambiguous case because we'll say because we're given, and we call this the side angle triangle. Okay. In order to consider the ambiguous case, we have to be given two sides and an uncontained angle. Okay. So actually, I'm going to add to this a bit. I'll say it's not necessary to consider the ambiguous case because we're given the side angle triangle, not side angle triangle. Okay. All right. So that's the criteria for the ambiguous case. Also, let's look at this triangle. Is it possible this could be drawn more than one way? So I know we just kind of answered that. We said no because we were checking the criteria. But also, if we just look at it, if these angles are fixed, that means these side lengths can't swing and be in a different direction. Okay. And this distance is also fixed as well. And in fact, when two angles are fixed, the third one's also fixed, and we're given this side length. So there's no way we can draw something else. I can't make this side bigger because that would actually end up changing the angles in here. So, all right, so you can even tell just by looking at it that there's only one possible triangle. Okay, let's go to part C. Now we're gonna be asked to solve for something. So it says determine the distance from Patina to Romeo. So that's this here. Okay. And green, I'm going to write PR equals question mark. That's what we're looking for. Okay, to the nearest tenth of a meter. And then it says if there are two answers, determine both. Well, there's only one answer because there's no ambiguous case. There's only one possible triangle. So there's only one possible length to solve for. Okay. All right, because this is the side angle type triangle, we are going to use sine law. Okay, so I'm just going to do this one in green. I'll say use the sine law. Okay, and remember when we use the sine law, I always write what I'm looking for first. So I'm actually looking for this length PR. I could also have called this lowercase q, right? Because it's opposite to the angle Q. Okay, so both would be fine. So I start with what I'm looking for. So I'm just going to say Q. I'm going to write that over sine of the angle Q. So that's my pair right here. I have the angle and I have the length. So that's now needs to be equal to another pair that I know. Well, I know this length and this angle. That's another opposite pair. So I can write that in. So I'll say P over sine P. Okay, that's the sine law, right? That those opposite pairs make ratios that are equivalent. So, okay, now to just fill in some of the stuff we know. So we don't know Q, but we know the angle Q. It was 72 degrees. And P, okay, lowercase p, that's this here, the 23. And sine of angle P, that was 55. Okay, notice this is going to be real easy to solve for Q now. All we have to do is multiply both sides by sine of 72. Okay, when we do this to the one side, that cancels out. So we're left with Q equals 23 times sine of 72 all over sine of 55. Okay, and we'll say, plug this in, 23 times sine of 72. And then all of this is divided by sine of 55, 26.7. Okay, so that's to the nearest tenth. So we'll say Q is approximately, with the dot, 26.7 meters. Okay, usually we just write a quick therefore statement. We can say therefore Romeo is 26.7 meters from Patina. Okay, so that is it for this example. So what you want to take away from this is you want to basically be able to read a question and then draw out the situation. And then you want to look at what kind of triangle you're given. If you're given a side-side angle triangle, then you're going to have the ambiguous case, which means there'll be two triangles to draw. Okay. If you're not, you can also look at that chart that we completed together in class, and you can look at the type of triangle you're given, and you'll know if you should use sine law or cosine law. So for side angle, we always just use sine law to solve for whatever we need from that triangle. Okay, that's it for this video. And the next one, we'll take a look at example 3, where we will see the ambiguous case. Okay, all right, I'll see you in the next video.